Hello and welcome to this episode of Text Analysis with Python. So in this episode I'm going to use Textacy, which is a very powerful Python library for NLP tasks built on top of spaCy, and I'm going to use that to do some very simple analysis of Joe Biden's State of the Union speech. So why are we going to use Textacy and what are we going to use this for? So we are going to install Textacy, and then we're going to get the number of sentences in that text, the number of words, the number of unique words. Then we're going to have a report of lexical density, how many unique words Biden used as compared to the older words. Then readability, although it's not something necessarily for reading, that was a speech basically, but we have a transcript, so we can measure the readability according to there are a lot of different ways to measure that. I'm going to use a simple flash reading ease, which has a number from 0 to 100, 100 being the easiest. A fifth grader can also read that, and also on 0 to be the most difficult. So we'll see which of these Biden's speech falls into. Then we'll grab the parts of speech, that is how many times verbs have been used, adjectives, nouns, and those things. Then we'll learn how to pre-process a text and to prepare it for the analysis, or how to clean the data, because the data could include, among other things, punctuations, hashtags, symbols, URLs, numbers, and all those things that we might not need. So how can we use Textacy to get rid of those? Then we'll extract n-grams, so we'll see what bigrams, trigrams, 4grams Biden has used, what are the most common ones that he's used. Also the key terms in his State of the Union speech. So what are the key terms? And we're going to use an algorithm text rank using Textacy. It's super easy, just one line of code. Then we'll also learn how to get those terms or words in a context. So we'll use keyword in context provided by Textacy. So we'll see how every word has been used in a specific context. So we'll focus on that. And an amazing part of Textacy is it makes it so easy to do things that you do with spaCy. So for example, with spaCy you have also patterns, matchers, but with Textacy is much easier. For example, you are looking for some specific patterns, like I'm looking for prepositions followed by adjectives followed by nouns, or I'm looking for prepositions followed by optional adjectives but mandatory nouns. So that is what it means. Okay, so these are the things we are going to do now. If you want to know more about Textacy, please go to the documentation page, textacy.readthedocs.io, and you will see this is just amazing. All right, I'm going to use Colab as my code editor, as I just did before in the previous tutorial. And I have this text file of Joe Biden's State of the Union. I just grab the transcript online. You can just find it online yourself, and you drag and drop it in this area. Now, what we need to do is we are going to install spaCy like we did before, and we're going to download this small English pipeline as well, and pip install Textacy. This is something new. Then you can import Textacy as well as spaCy. You don't need that for now, but I'm going to show you why I imported this as well. The next step is to read the content of that State of the Union file. So we use the with statement in Python to open that text file in the reading mode R, and we're going to give it a name. We're going to know it as, for example, F or file or whatever. And we're going to read that file by read method and assign the result of that reading, the content, to this variable text. So text is basically now the content of our file in a string format. Now, since my file has like new lines, as in these symbols for \n, I'm going to replace every \n with an empty string, That is, just remove those. So now text is the content of that State of the Union. All right, so now we have this. Now we can do either of these two things to use Textacy. We can either create a document object, just like we did before with spaCy. That is, we're going to load the small English pipeline of spaCy into this variable NLP. We are going to apply that NLP to our text, this text, and then we'll have a document. And that document is just a text with a lot of annotations. You saw that before. So with a lot of information on every token. This is one way to do it through spaCy, and I just did it so that you know Textacy works really well with space documents. Or you can do it directly through Textacy by creating a document, textacy.make spaCy doc, give it the text like this, and language is equal to the small English pipeline. Either way works. Okay, now let me see. Okay, I'm going to run these. You will see. Now, first let's start with the statistics. To grab some statistics about our text, we can import text_stats from Textacy. And let's run that one. And now the number of sentences. So we use that text_stats dot basics dot n_cents and pass in the doc. Remember, this is a spaCy doc. Let's run that and see how many sentences do we have. This many. What about the number of words? Text_stats dot basics dot n_words, pass in the doc. How many words? 6,637. What about unique words? Again, text stats basics n_unique_words, pass in the doc, and 1,700. Okay, interesting. So we have this many unique words compared to the whole words. All right, that means almost 1/4. Now we can get the lexical density, which is a ratio of the number of unique words to all words, that ratio of types to tokens. So we use text_stats dot diversity dot ttr, that is type to token ratio, pass in the doc, and we have 25% of the words are unique. Great. Okay, now what about dependency relations? How many times, for example, I don't know, nominal subjects appear? How many times do we have objects? That is simple. This time, instead of basics or diversity, we use counts. So text_stats dot counts dot dep for dependency, pass in the doc, and let's see what we get. So we are getting the root, which is 474. We have determiners here, 479 determiners like there, and then we have auxiliary verbs, for example, 419. We have nominal subjects, 654 times. We have direct objects, 479. That's a lot. And then we have, for example, I don't know, a lot of stuff here. So you can just read through them. Then let's grab this information about the number of times each coarse-grained universal part of a speech. Coarse-grained means it is very general. For example, it says, I don't know, preposition. But it doesn't tell you if that preposition is a part of a phrasal verb, like look up, look for, look after, or something like at school, at. So now, textstats.counts.pos for part of speech, and pass in the document, and you can see we have all these proper nouns, for example, 471, adjectives, 481, verbs. You see, for example, verbs, we have 1,004 verbs, so it's a very verb-laden kind of speech, but it doesn't tell you if that verb is, I don't know, past or third person, singular or whatever. So that's why it means like coarse-grained. Then to get a more fine-grained analysis, we have textstats.counts.tag and pass in the doc, and this is what we get here. For example, you can see Now this is fine-grained, meaning we have plural nouns, we have 494, singular nouns, we have 883. In the coarse-grained, there was no difference between these two, so we just had nouns. And here you have noun phrases, or sorry, proper nouns, for example. Then you have different types of verbs here, like we have third person, present, and all that, or past. And we have symbols. Now, another piece of information which could be interesting is the number of times each value for a morphological feature appears as a token annotation. So I'm going to explain what that means. So we have text_stats dot counts dot morph, and morph is so in linguistics we have morphemes, or here it says morphological feature. So a morpheme is basically the smallest meaningful unit of a language. For example, in a word like teacher, we have two morphemes. One is er, one is teach. So, wow, what is the meaning of er? Well, we know that most of the times er turns things from a verb to a noun. So that's why it has meaning. It adds to the meaning of teach or teacher. So that's why. So these are morphological features. Okay, now let's run this one and look at this. Here we have definite. So definite noun phrases like with the or with a, for example, like the book or a book. So definite and indefinite. Then you have pronoun type, we have articles, we have relative pronouns, indefinite, and demonstrative, like this, that, those. Then you have degree, for example, for adjectives. You have positive, meaning it's a degree of comparison. If it's positive, it means it does not compare anything. It says, for example, good, lies in good book. That would be pos. But if you say better, that would be comparative, and best would be superlative. So you can see that Biden has used a lot of these as well here. And then you have verb form, a finite, infinite, and others, participle or gerund, gender, you can see that here as well. And yeah, mood, indicative. So you can just actually read about these. If you go to universaldependencies.org, you will see something for dependencies and in the documentation here as well. So universaldependencies.org, and you will see a list of these dependencies. So that's good to know for more information. Okay, now what about readability? So as I said, I'm going to use the flash reading ease. There are a lot of different options. Well, maybe not a lot, but there are several different options that Textacy provides. One of them is flash reading. So text _stats.readability.flashreadingease doc, and let's see what we get. So we get 78, meaning the State of the Union speech was not very difficult to understand, obviously. It was not also like a kid story. So it was almost, what was that? Almost 80. So around here. For 7th grade, fairly easy to read. In this case, I would say fairly easy to understand. Well, it was not a conference, a physics conference after all. So, okay. Now we get to the cleaning part or pre-processing part. So for that matter, we are going to import pre-processing from Textacy. Now let's say we have this text that I've called txt. And this text has, as you can see, exclamation mark, we have colons here, we have an URL here, and we have two different signs here. How can I clean this text so that I get only, for example, this and is, and something like a website? How do I do that? Well, I just imported pre-processing. So what I can do, I can say pre-processing dot, and it gives me several options: normalize, remove, replace. I'm going to say remove, and I'm going to remove some punctuations. So I'm going to remove punctuations from our text. That's what I'm going to do. So then let's see what happens after that. So now you see, well, actually I should assign this to text, let's say text2. So text2 is a result of that removal of the punctuation. And let's see what happens. So now you see we have no exclamation mark, we have no columns here, and the dots are gone, the periods are gone, and also the hashtag is gone as well. So that's one of the ways you can get rid of the exclamation mark, quotation marks. What if I have like this, quotation marks here? You see, it also gets rid of those as well. Very good to have. But what about this? What about this $sign? So I can specify that, I don't know, delete some specific stuff, for example. So I'm going to show you how to do it here. So down below, I am going to use a more customized version of preprocessing. So I'm gonna import partial from Func Tools. I'm going to show you why I'm importing that, and I'm going to create a new pipeline, call it preproc, whatever you want, and it's going to be preprocessing dot make underscore pipeline. So we're going to make a new pipeline, a new series of steps to preprocess our data. So what's that going to be? I'm going to remove HTML tags. So I'm going to use preprocessing.remove.html underscore tags, just in case there are HTML tags. Then I'm going to say also preprocessing.replace.urls. Also replace the URLs. That is, replace them with what? You will see. It's also going to normalize the Unicode characters. And here is the part that I told you with partial. So I'm going to say preprocessing.remove.punctuation, and I'm going to say only remove these when you see them in a text. So I want to keep, for example, periods. I'm going to keep question marks, for example, and some others. So only remove these. So that is why I've used partial here. Then I'm going to also remove emojis. Let's say I have also some emojis here. I'm going to remove that as well. And I'm going to get rid of also white spaces. So preprocessing.normalize.white space. Okay, that's what I'm going to do. Now, let's do that. Let's just run this. So now I have a new pipeline called preproc that I can apply to my text, this one here. So let's call it clean text equals preproc this pipeline, and let's give it this text, which is this one here. Let's see what happens to it, and I'm going to print it later. Let's see what I get. Look, this is, we have kept this colon because I said only delete these, and the URL has been replaced by underscore URL underscore. Why? Because here we just said replace URLs. I didn't say replace it with what. So let's just do it here. I'm going to show you how it works. Let's say text2 equals replace underscore URLs. Oops. Dot, actually, not underscore. Dot URLs, and I'm going to do that replacement on text and replace it REPL with what? Let's call it website. Web site. Yeah, like that. Now, if we run this, you see this is website. So when it sees a URL, it replaces that with the word website. But if you want to remove it altogether, you can just leave it blank here, and you can see now it's gone. It's no more. Okay, so that is how it works. So we just created a pre-processing pipeline, and we added these to it to remove the HTML tags, replace URLs, normalize Unicode, remove some punctuations, replace the emojis, and normalize white spaces, because you might have white spaces, I mean, more than normal. Okay, Now that we've done that, let's extract some information from spaCy, from Textacy, while using Textacy from our text. Now, n-grams. So I'm going to say, let's just have something like, I don't know, n 3 for 3 grams or trigrams, en3. So now I'm going to extract basics. So this is extract that I just imported. Extract basics.ngrams, the document, spaCy document. The number is going to be 3, that is 3 grams. That is 3 characters next to each other. If they happen at least 3 times in the document, and I want you to filter out stop words. So let's just say true, meaning I don't want stop words like in, at, the to be in these 3 grams or trigrams. I don't want them. So, well, normally you should set it to false. I just put it here so that you know, because they might be useful depending on your use case. Then punctuation, filter it out. Yes, I don't want any punctuation to be included in the trigrams. And then filter numbers. I don't want numbers, but let's just keep them here. And you can either, actually you don't need any of these. These are optional. But I've just included them so that you know. And include part of speech underscore POS. I'm gonna say, try to find the n-grams or 3 grams that include pronouns and verbs. So remember again, we don't need to have this at all. But if you just want to restrict it a bit, you use that one. And after that, since this is going to be, I cannot, so if I just go like this, let's see, the type is going to be generator object. So I can turn it into a list so that it will be printable. At least we'll see what it is. Now you see we have let's get. So this is something that has been repeated in Joe Biden's speech, and it follows like there's a verb in it and a pronoun. So now if I make it a bit, like 2 times at least, let's see what we get. He thought he, let's make, let's get, let's pass, let's stop. So these are the 3 grams. And you might say, why, how is let us make is a 3 gram or trigram? Because apostrophe S is also a separate independent token. That's why it includes it as one. Let us make, so that's like 3 words or tokens actually. So this is something that we can have. Now, another important and interesting thing is getting the key terms in Joe Biden's speech. So based on text rank algorithm, so we're going to extract .keyterms.textrank, and we give doc as the argument, and these are the key terms: new manufacturing job, new economic vision, American people, American job, young transgender Americans, new law, fellow Ukrainian Americans, new vaccine, new mask guidelines. So you can see the important topics that were discussed in this State of Union. Now, another thing is the matching patterns that I talked about. So to extract the matching patterns, we are going to use this extract that we imported here, .matches .token underscore matches. So we're going to pass in doc, the document, and we're going to pass in the pattern that we want Textacy to find. Inside a list, we're going to pass in different dictionaries. And inside every dictionary, we can have several key value pairs. For example, we can say, find me a pattern where the first word in that pattern is, the part of speech of that token is a determiner, and OP, meaning optional, true. So it should be optional. So find me something in which the first one is, but it doesn't have to be, a determiner. Then right after that one, find me something, and I mean the second part of this 3-word sequence is going to be an adjective. Optional, you say no, there should be something, there should be a word here. And after that, let's have a noun, and it should not be optional. So here, imagine, we should find 3 grams or 2 grams where the first part is optionally a determiner, the second one is an adjective, the third one is a noun. Now, again, it's a generator object, so we're going to turn it into a list and print it. And look what we found. The American people. So the is a determiner, American, adjective, people is a noun. Unwavering resolve, adjective, noun, because we said this should be optional, this, the. So this is amazing. Seriously, this is just crazy. Okay, and the last one, and my favorite, is the keyword in context. So I've just created this variable ek for this keyword, and I'm going to use extract.kwic.keyword_in_context. We pass in the document, and we are looking for this keyword people. And we are setting the window width to 25, meaning find me the context that people has been used in. Give me the 25 characters before and 25 characters after. And I'm going to say for I in list of ek, so turn all these examples into a list, go through the list and print every item, and this is what we have. Look, we have the keyword, another to the American people, to the Constitution. He met the Ukrainian people from President Zelensky, with the Ukrainian people throughout our history. So this is the context in which this word people has been used. Now you can tell more about the meaning of this word based on the context. Okay, so this was a very simple analysis into the State of the Union speech. So we just grabbed some statistics about the words, the sentences, the lexical diversity, about the part of speeches, about morphological features, about the n-grams, keywords, key terms, keywords in context, and all that. Well, I hope you liked this video. If you did, please leave a like and share it with others. Thank you very much for watching and listening.